Dear world, welcome back to today's session of dynamic programming. Today we'll be understanding the dynamic programming in detail. So without wasting time, let's move to the content. First, we'll be studying what is dynamic programming strategy. So the basic concepts of dynamic programming. Say third, steps to solve DP dynamic programming problems. Properties of dynamic programming. Next, we'll be observing the greedy and divide and conquer versus dynamic programming. That means what is the difference between greedy and divide and conquer and dynamic programming. First, what we got in our programming, that was greedy, and from greedy we got the divide and conquer, and from divide and conquer the dynamic programming came into existence. So we will show the entire evolvement cycle. Third, the recursion is the base. That why recursion is the base of dynamic programming. Seventh, dynamic programming approaches. So there are two approaches of dynamic programming, that is top-down approach and second bottom-up approach. So both the approaches we will observe here. Comparison of memoization versus tabulation, understanding of DP approaches with Fibonacci series. So in today's video we'll be taking the example of Fibonacci series. So let's start from understanding what is dynamic programming strategy. So first we are starting that what is this dynamic programming strategy. So dynamic programming is actually optimization technique. We use this dynamic programming data structure for optimization. So when we try to use this dynamic programming for optimization, so there are few scenarios. First scenario is when you get a optimal substructure. Optimal substructure, that means when you get something structure like this. Let's say there is a tree that I'm gonna show you right now. Tree. So there are a lot of problems. In every problem we get a solution here. We get a solution here. So in every section we get a solution. So this is optimal, that every sub problems is providing a solution. So this type of solution is called optimal substructure. When we get a optimal substructure, and this is typically a concept of greedy algorithm. So first thing this. Second thing is when we get repetition. That means while solving the program we get something repetitive, that some values are getting repetitive again and again. Our program is calculating the same value again and again. So if we get repetitive manner. Third, if we see that in some problem we are able to apply the recursion. That means we should understand that this is the place where we can apply the dynamic programming. So if we are applicable to apply the recursion, so we should try to understand that this is the place where we can apply the dynamic programming. So this is all about the dynamic programming strategy. Now second, we'll be observing key concept of dynamic programming. So that are the main key concept that I already told you. So let's study the key concept. Is a powerful technique used to solve optimization problems. So this is used to solve optimization problems. Those problems where you will get the questions. I mean, you will get the main motto like this: minimum or maximum, longest or smallest. So anything of optimization where the value will be only one. That type of place when we will be getting, that is you need to understand, that is dynamic programming. Number one. Number two, in dynamic programming you always solve the problem by breaking into smaller pieces. By breaking down into smaller sub problems. That means any problem, if we are able to break into smaller pieces, then we get to understand that is the place where we can apply dynamic programming. DP is particularly effective when the problem can be divided into overlapping subproblems. One more fact, that here the more important thing is the subproblems will be overlapping. That means subproblems will be same. So that is the main concept, that here the overlapping, that means same problems, same subproblems. And here, because of the same problem, what we do, we waste our time, and it takes a long time. Because we waste our time in every calculation, it leads to very high exponential time. Of e to the power x. So we apply dynamic programming here to reduce the time complexity to linear or polynomial time complexity like big of n or big of n square, or with the help of dynamic programming we reduce to big of n cube. So what we do, When we get same type of overlapping subproblems, we memorize it. So we'll be understanding this in more details using Fibonacci series. So this was the key concept of dynamic programming. Steps to solve DP problem. So before we understand the steps to solve DP problem, let's understand the dynamic programming with the help of Fibonacci series. Okay, I got a perfect place. So now let's guess we are taking the example of 5 Fibonacci series. So now we will be trying to find Fibonacci series. So first we should know what is Fibonacci series. Fibonacci series is a series that it starts from the value 0, 1, 2, 3, etc. And at every index the value is the sum of previous two values. That means in series where the sum of current index is the sum of previous two value is the sum of previous two values. So that is Fibonacci series. So now we'll be trying to get the Fibonacci of 5. So what will be the Fibonacci of 5? It will be the Fibonacci of 4 plus 3, because as you told, the sum of previous two values. So previous two values, one will be Fibonacci of 4 and previous of it, that is Fibonacci of 3. So this is Fibonacci tree. So we'll be constructing that Fibonacci trees. So let me remove this. We are keeping it just here. Okay. So now we'll be constructing the Fibonacci tree. So let's draw it. Fibonacci of 5. So Fibonacci of 5 is coming from where? Fibonacci of 4 and Fibonacci of 3. So we'll be keeping the 3 in left side because that is smaller. Now this is actually into the binary tree rules, so that we always follow all the data structures whenever we draw also. So Fibonacci of 3 comes in the left side, Fibonacci of 3, and now Fibonacci of 4 in the right side. Now again we'll be breaking this 4. As we know that Fibonacci is the sum of previous two values. So 3 sum of what? 3 sum of previous 2 and 1 values. 2 and 1 values. So we break it. Fibonacci of 2 plus Fibonacci of 1. Whenever we get 1 or 0, whenever we get 1 and 0, we'll be stopping that here. So this is the 1 and 0. In Fibonacci, whenever we get 0 or 1, we should understand that that is the stopping condition. That is a stopping condition. We will not break more further. Stopping condition, we will not break more further. So if we get 1 and 0, we will stop thinking that that is the stopping condition. Okay. Now we draw Fibonacci of 1. Now we get Fibonacci of 2. So what is this 2? 2 equals to 1 plus 0. So we'll again break this Fibonacci of 2 into Fibonacci of 1 plus 0. So okay, let's break it. Fibonacci of 1 plus Fibonacci of 0. So we broke this problem Fibonacci of 5 into so many smaller chunks. Now Fibonacci of 4. Now we'll be breaking this Fibonacci of 4. So the previous two values of 4 is what? 3 and 2. So it is Fibonacci of 3 plus Fibonacci of 2. Now we again divide this Fibonacci of 3. Sorry. Okay, it's okay, but we could write like this. It would be more better. That this is Fibonacci of 2, Fibonacci of 3. So let's keep Fibonacci of 2 this side, Fibonacci of 3. Now we break Fibonacci of 2 again into, so this is the sum of previous two values, that is 0 and 1. So Fibonacci of 0, Fibonacci of 1. Fibonacci of 1. Again we break this Fibonacci of 3. So the Fibonacci of 3 gets break into previous two values 2 and 1. So this is Fibonacci of 1, and whenever we get the Fibonacci of 1, the stopping condition, so we stop here, and Fibonacci of 2. So we'll again break this 2 into smaller problems. So that will be okay. So that will be Fibonacci of 2. So if we divide the two smaller, that is 1 and 0. So we keep Fibonacci of 0 plus Fibonacci of 1. Now observe the main things to notice here. The main things is to notice here is if you observe it, if you observe the entire tree. Look, here we get the 0. We got 0 for first time. We got 0 for second time. We got 0. We got 0 for third times. So we are getting this 0 for many times. That means we got only the Fibonacci of 0 for 3 times. Now if we try to find Fibonacci of 0, we got this Fib of 0, Fib of 0 to 2 3 times. Now we try to find the Fib of 1, Fib of 1. So first time, second times, third times, fourth times, and here 5 times. So we got for 5 times. Now try to understand what happens here. What happens here is we are getting Fibonacci of 0 is 3 times. That means the calculation is done for 3 times. The calculation is done for 3 times. We are getting Fibonacci of 1. The calculation is done for 5 times. But do you need to calculate the same things again and again? If we would calculate this Fibonacci of 1, then the time complexity would become just a big of 1. Big of 1. But what it happened here is that we are calculating the same Fibonacci of 1 for 5 times. For 5 times, and it is increasing our time. It is increasing our time, leading to exponential time complexity. And that's why we come to dynamic programming. What dynamic programming tells us that why to compute again and again. Why will be computing the same things? Fibonacci of 3 is, now look, observe here. We got this Fibonacci of 3. This is also Fibonacci of 3. And this is also Fibonacci of 3. So dynamic programming tells us why to compute the same value for 2 times. We will be computing for only one time. Only one time. Why will be computing this Fibonacci of 0 for 3 times? We will be computing for only one times. Why will be computing this Fibonacci of 2? There is Fibonacci of 2, and there is also Fibonacci of 2. There is also Fibonacci of 2. So there is Fibonacci of 2 also multiple times. So why we will calculate for multiple times? Instead, we will calculate for only one times, and for that will be applying approaches. What might be the approaches? Just guess. If you knew the value of Fibonacci of 3, so the value of Fibonacci of 3 will be Fibonacci of 2 and Fibonacci of 1. So let's try Fibonacci of 2. What will be the value of Fibonacci 2? That is 1 and 0. So both the values would get the summation of 2. So if we would store it, if you knew the value of Fibonacci of 2, so we would store it in somewhere, and that would provide us a value. So we try to store those values, store the same values what we get, to store somewhere. We try to store value to reduce computation. That what we got the value, we will not compute for the second time, and that computation leaded us to memoization. Memoization, that means we memorize, and this is called memorization. When we memorize the value, memorize the calculation, that is called memorization. And this technique is called top-down approach. This technique is called the top-down approach. So we understood the main approach of dynamic programming is top-down approach. Here what we try to do here, we try to assign those values into some places. We try to memorize those values, and from the memorization we try to come into smaller problems. So this is called top-down approach. The second approach, what we can do to find the same values, is like this. That was top-down approach, and let's write it bottom-up approach. There was another more approach, that is to find value. What we could do that, we got the value of Fibonacci of 0 and Fibonacci of 1. So the value of Fibonacci of 0, the value of Fibonacci of 0 is 0, and the value of Fibonacci of 1 is 1. So this is the value of Fibonacci of 0, 0, and Fibonacci of 1 is 1. And the generalization of Fibonacci is Fibonacci of n is the value before it, Fibonacci of n minus 1, plus before the second also n minus 2. So this is generalization. So how could we compute the entire value up to 5? We could do like this. First we could calculate for 0 and 1. We have already for 0 and 1. We could calculate it for second time, third time, fourth time, like this. We know 0 and 1. Now we could calculate the Fibonacci of 2 like this. That would be like Fibonacci of 1 plus Fibonacci of 0, and that would be 1 plus 0, 1. Next time we could calculate the Fibonacci of 3. So it would be the previous 2, that is Fibonacci of 2 plus Fibonacci of 1. So that will be 1 plus Fibonacci of 1. So now we will be converting it to dynamic programming. We'll be converting the Fibonacci recursion. So what we do in the dynamic programming, we try to utilize, we don't compute again and again. Instead we use memory. So if memory comes into the play, that becomes the application of dynamic programming. So if we try to memorize, if we try to apply the memory, it becomes the problem of dynamic programming, or the application of dynamic programming. So now we will just insert the memory. Previously our code was where is the code? This was, look, this was the first condition, this was the second condition, and now this was the third condition. So if I just take the same conditions from here, okay, I can't take it from here, we are keeping it there. So this, if we will write the same code without any further changes, the same code we will write, we'll just insert one line to memorize the memory. So now we'll be inserting line. Okay, so first to memorize anything in program, what we create array. So first we'll be creating array to memorize for all the n+1 item. So now we'll be creating the array. So let's declare array integer Fibonacci. Let's call it integer Fibonacci. Integer Fibonacci, that is equals to new integer n+1. So now we declared memory. We have declared this memory, and now we'll be storing all the values in here. So first again we'll be writing the same function, public integer Fibonacci. Public integer Fibonacci. We write the same function, and now we are passing integer n. Again n value is passed. Now we'll be writing the base condition, that is if n equals to 0. If n equals to 0, so what we will be returning? We'll be returning 0, the base case. We'll stop here. This is our stopping criteria. Second, we'll write the second stopping criteria. If n equals to 1, then return 1. We could write this entire code in one line also, like this. If n equals to 0, if n equals to 0 or n equals to 1, return n. We could write in this manner also, that is same things. So first we wrote the stopping criteria, stopping conditions. Now we will calculate value and we will store it in here. So Fibonacci of I. So now we'll be checking that if it is not, before we check, now we will be storing the value. So return Fibonacci of n. Now look, this is the step where we are utilizing or we are saving the memory. Fibonacci of n, that is equals to Fibonacci. So this is the recursion applying Fibonacci of n minus 1 plus Fibonacci of n minus 2. So we applied recursion from here. Fibonacci of n minus 1 and Fibonacci of n minus 2. Fibonacci of n minus 2. So that is the application of Fibonacci. So before this application, we need to utilize this memory. Now all the values that we create here, it will get stored in here. That will get stored in that section. But we have to utilize that also. So we will be utilizing. We'll be checking every time before we make any call. Before we make any call, we'll be checking. So we now provide a check here. If Fibonacci of n that is not equals to 0, that is Fibonacci of n not equals to 0, then we will be returning Fib of n from here. Then return Fib of n. So we'll be returning Fib of n from here. That means if the Fibonacci of n value is not equals to 0, So we'll be returning Fibonacci of n from here. So that is the case. Now we have stored all the things in this memory and we will be fetching from this memory. We'll be fetching all the value from that memory. So we are utilizing memory here, and that becomes dynamic programming. So we can also call the dynamic programming DP, this dynamic programming that is equals to recursion plus memoization, that is overlapping subproblems plus memoization, that is overlapping subproblems plus memoization. So if you get those overlapping subproblems plus memoization, it becomes dynamic programming. Now we'll be looking the second method, that is top down. So let me tell you why this name is top down. Look, we started this program from 5. So after this 5 is divided into 4 and 3, because n minus 1, n minus 2, 4 is getting divided into 3 and 2, 3 is 1 and 0. So from top value 5 we are decreasing the Fibonacci, that is equals to new integer n plus 1. So this is memory declaration. We have declared the memory here. Now we'll be writing the function name, that is public static integer Fibonacci of integer n. Now we'll be checking the base criteria, that is if n equals to 0 or n equals to 1. Then if you get 0 or 1, we'll simply return n, or we will assign few values to Fibonacci of 0 and Fibonacci of 1. Fibonacci of 0 we assign as Fibonacci of 0 to be 0. So we keep Fibonacci of 0, that is equals to Fibonacci of 0, and Fibonacci of 1, that is equals to Fibonacci of 1. So for 0 and 1 we have got the value. Now we start for building. We will know the value of 0 and 1. We'll be starting building for 2, 3, 4, 5. So we need a loop for this above. So for integer I equals to 2, I less than n, I plus plus, Fibo of I, that is equals to Fibo of I minus 1 plus Fibo of I minus 2, because at every step the Fibonacci is the summation of previous two steps. So this will run up to the value of n, and at the end we will get the Fibonacci from here. So after the loop ends, we'll simply return Fibonacci of n, and this will construct out the Fibonacci series. So this is here we utilized the iteration. We utilize the process iteration or tabulation. This is called iteration or tabulation. So what happens here, that every value is stored in iteration format. So these are stored in arrays, like what we can also represent like this. The table is itself array. So this method is also called iteration or tabulation method. So we got to understand the iteration and tabulation method. The more important things is, if you apply more idea here, we can also optimize this section. We can also optimize this section like this. First, what was that our function, that was public integer Fibonacci of integer n, and our integer Fibonacci of 0 was 0, integer Fibonacci of 1, that was 1, and for summation we just did integer sum. So initialize this integer sum equals to 0. Now we start a loop from here. For integer I equals to 0, I less than n, I plus plus, and we just sum becomes the Fibonacci of 0 plus Fibonacci of 1, and now we just update those values. We just update those values in the next step. Fibonacci of 0 equals to Fibonacci of 1, and Fibonacci of 1 equals to sum. We just update those values, and at the end we just return sum, so we get the same optimization, and now it is optimized. Previously those the time complexity in here was big O of n, and the space complexity also was big O of n both, but here the time complexity is big O of n. The time complexity here the time complexity is same because it runs for n times, so that is big O of n, but the space complexity is reduced. Space complexity is reduced to big O of 1 because we are only using one variable to store the memory. So these are all the optimizations made possible with the uses of dynamic programming. So that is all about dynamic programming concept, iterations, etc. And that is also the PPT. If we would study the PPT, we could understand the concept more clearly that I told you all. So now we'll be looking the top 20 dynamic programming patterns. So these are dynamic programming patterns. Fibonacci pattern. So we had to study Fibonacci pattern. We already studied. Second, knapsack pattern that we'll be studying. Unbounded knapsack pattern, longest common subsequence pattern, longest increasing subsequence pattern, edit distance pattern, palindrome substring pattern. So there are a lot of patterns. In the next session we'll be studying all the patterns one by one, and to have a strong command with the data station algorithms, stay connected with me. Subscribe to my channel and stay in my touch. Thank you. That's all. We are ending this session here.